Hello everyone. So in today's lecture we will discuss about Claisen-Smith condensation. Now Claisen-Smith condensation is a special type of aldol condensation and it has a high degree of similarity with aldol condensation because of common intermediate. Both aldol condensation and Claisen-Smith condensation involves formation of enolate ions as intermediates. But the difference lies in the fact that in aldol condensation both the aldehyde molecules or both the ketone molecules possess an alpha hydrogen atom. But in case of Claisen-Smith condensation, one of the aldehyde will be basically an aromatic aldehyde with no alpha hydrogen atoms and it will condense with an aliphatic aldehyde or a ketone or ester with alpha hydrogen atoms, and this reaction basically takes place in the presence of an alkali solution. So the final product for Claisen-Smith condensation, just like aldol condensation, is alpha beta unsaturated aldehyde. Now since this is a condensation reaction, one molecule of water will be a byproduct along with the alpha beta unsaturated aldehyde. Now I have given in these slides three examples in which in the first example benzaldehyde condenses with acetaldehyde in the presence of 10% sodium hydroxide to give an alpha beta unsaturated aldehyde, in this case is cinnamaldehyde. Similarly, benzaldehyde condenses with acetone in the presence of 10% sodium hydroxide to give benzylidene acetone. So benzaldehyde also condenses with ethyl acetate. Now ethyl acetate also contains 3 alpha hydrogen atoms in the presence of 10% sodium hydroxide to give ethyl cinnamate. Now all three are examples of Claisen-Smith condensation. Now let us discuss the mechanism of Claisen-Smith condensation. Now as I told you earlier that Claisen-Smith condensation involves formation of enolate ions specifically because of the presence of an aldehyde or a ketone or an ester with alpha hydrogen atoms. We all know that the alpha hydrogen atoms in case of acetaldehyde or acetone or ethyl acetate are weakly acidic in nature, and it can be abstracted by strong bases, in this case sodium hydroxide. So abstraction of a proton by the alkali or by the base gives you an enolate ion, and this enolate ion is resonance stabilized. Now this enolate ion acts like a nucleophile and it attacks the carbonyl carbon of benzaldehyde, because as you know that aldehydic carbonyl groups or ketone carbonyl groups are prone to nucleophilic addition type of reactions. So which makes this pi bond to shift towards oxygen to form an alkoxide anion. Now this alkoxide anion abstracts a proton from the solvent used, which is water, and this hydroxylated derivative will lose one molecule of water to give alpha beta unsaturated aldehyde. So the final product in case of Claisen-Smith condensation of benzaldehyde with acetaldehyde is cinnamaldehyde. A similar mechanism is also seen in case of Claisen-Smith condensation of benzaldehyde with acetone. Here the enolate ion is formed by the abstraction of a proton from one of the methyl groups of acetone to form a enolate ion. Now this enolate ion once again will attack the carbonyl carbon of benzaldehyde, and finally the other steps will be the protonation of the enolate that alkoxide anion formed, and that will ultimately lose one molecule of water molecule to give a condensation product. In this case, it will be benzol acetone.